Okay, so first of all, Vint, thank you very much for talking to the students at the University of Waterloo. Many of them go on to work with Google and other large technology organizations. So this will be especially useful for them, I think.
Well, I'm delighted to do this, Peter. You should know, of course, that I've had friends at the University of Waterloo for many years. But I'm thinking of Donald Cowan, for example, among one of them in particular, and Eric Manning is another. And of course, Dave Sheraton at Stanford has been a great sponsor of Waterloo, given that he graduated from there. So I have a good resonance with the organization, and a lot of respect, by the way, for Waterloo's ability to bring students together with people in industry. You have one of the best placement programs I've ever seen at any university anywhere.
That's very kind, Vint, and thank you very much. Can I begin the interview? We're going to cover a number of aspects of the internet and its impact on the world. But the first thing I'd like to do really is to ask you to tell us a little bit about yourself, and I'm particularly interested in what you see as the highlights of your career so far.
Well, remember that we're covering 40 years of activity in a short amount of time. Plainly, my early involvement in the ARPANET work opened up an opportunity for me and many others to continue to explore networking technology. And it was the experience with the ARPANET that I got at UCLA in the late 1960s that led very directly to my partnership with Bob Kahn to explore what we now call Internet. That was in part motivated by the exploration of packet switching in different media, whether it's mobile radio or shared packet satellite channels. The creation of those kinds of networks, a mobile radio net and a packet satellite net, led very directly to the question, how do we connect all those nets to each other? And of course that led to the first paper describing how one could do that in 1974. I was then very fortunate to move to the Defense Advanced Research Projects Agency in 1976 to continue the program of research which had started for me at Stanford and of course for Bob at DARPA. Having finished that work around 1982, late 82, just as the Internet is being launched on January 1st, 1983, which is the real birth of the operational Internet, I went into the private sector to build something called MCI Mail, which later on was connected to the Internet as an experiment around 1988. By that time, I had left MCI, where I'd been in the commercial sector, rejoined my partner Bob Kahn in research at the Center, or the Corporation for National Research Initiatives. That led to a breaking of a rule, which up until that had been that the government-sponsored backbones in the United States would not be allowed to carry commercial traffic. So we were given permission to allow this commercial MCI mail system to pass traffic through the government backbones. By 1989, when we were operational with that connection, all of the other commercial email service providers said, wait a minute, those MCI guys can't have that special position. And they said, we want to be connected too. And the Federal Networking Council said, well, okay. So by that year, 1989, two big things happened. Three commercial internet service providers came along, PSINet, SurfNet, and UUNet. And of the three of them, the UUNet had, of course, turned out to be a really big player in this game. It still persists as part of Verizon now, when Verizon acquired MCI. But the other thing that happened is that when the other email service providers insisted on being connected to the Internet, they hadn't anticipated that this would also cause them to be connected to each other. Whereas prior to that time, they were walled gardens and couldn't communicate. So there are two very salient effects of making that interconnection. I'll try to keep not to go on forever here, but I think the next big and important milestone comes when Tim Berners-Lee invents the World Wide Web and sort of launches it on December 25th, 1991, if memory serves. This was a relatively unnoticed launch at the time. But not very much after that, Mark Andreessen and Eric Bina wrote a graphical version of the World Wide Web browser, which they called Mosaic. That caught everyone's attention. for some value of everyone. Jim Clark, who was the founder of Silicon Graphics, got very excited about what he had seen in the way of Mosaic and this graphical World Wide Web, and together with Mark Andreessen, founded Netscape Communications. The IPO for that around 1995 started the dot boom during the next 5 years or so until April of 2000. Since that time now, for the last 12 years, the internet has been growing approximately 15% per year compounded annually. 2.3 billion people are online. 900 million machines are seen as part of the publicly visible domain name system. And probably another 2 billion or so are online episodically, including some of the 5.5 billion mobiles that are internet capable. So my career has been persistently involved with the internet, except for a little 4-year period when doing MCI Mail. I've been fortunate to be the founding president of the Internet Society, to be a member of and then chairman of the board of ICANN, the Internet Corporation for Assigned Names and Numbers. I now sit on the board of ARIN, the America's Registries for Internet Numbers, and I have a career which continues to be very much involved in especially policy associated with the Internet, and in particular global policy. Final point, it's 2012. We ran out of IP version 4 address space in February last year. We tested IP version 6 on a 24-hour basis on June 8th in 2011. In 2012, on June 6th, not very long from now, Google and everybody else that's capable of doing it is going to turn on IPv6 and leave it on. So 2012 is IPv6 launch year, and we are hoping that this will get enough attention that more people will implement IPv6 so we can continue to grow the Internet, to incorporate the Internet of Things, sensor networks, smart grid, and all, of course, many of the other devices, appliances in the household, in the office, in the car, and things we carry around on our bodies, are all being part now of this growing environment.
So, did you have any sense when, as the internet was starting, Vint, that it would become what it's become? Did you have a sense of how big this would be?
One honest answer, of course, would be no, but that wouldn't be accurate. A more precise answer is that Bob Kahn and I and others who were involved in this program actually were very well aware of how powerful this could be. And as evidence of this, I would point out that when we started the work in 1973, in the spring, Bob Metcalf and his group at Xerox PARC, which is 1.5 miles from my lab at Stanford, were working on the Ethernet, which was essentially invented around May of that year by Bob Metcalf and David Boggs. Moreover, we had now 3 years of experience, or 4 years of experience with the ARPANET, and the ARPANET had opened up the pathways to networked electronic mail in 1971. It had Doug Engelbart's online system, which actually existed before the ARPANET did. It was kind of like a one-computer World Wide Web. It had hyperlinking. It had portrait mode displays. It had a mouse, which Doug Engelbart invented for pointing at places in the display, telling the computer how to manipulate documents that you were working on. It was a tour de force of technology for collaborative work on text-based systems. So we had that. It was in operation and available to us on the net. Of course, we had remote access to time-shared systems, and we had file transfer, and we had email, which I've already mentioned. So we already had that in place. In addition to that, we had the mobile radio network, and we had the second packet satellite net, and of course Ethernet, in addition to the wireline ARPANET, to look at. And we'd already started to see some of the social implications of this kind of technology. Not very long after email was introduced by Ray Tomlinson, who picked the @ sign to separate the usernames from the hosts where their mailboxes were located. After Ray got this up and running and everybody decided it was a killer app, there were distribution lists created, and one of the earliest ones was called SF Lovers, which is science fiction lovers, what do you expect? It's a bunch of geeks who are working together. And the other one that I remember was from Stanford. It was called Yum Yum, and it was a restaurant review list for restaurants in the San Francisco Bay Area. So, almost instantly, email shows itself as a substrate for social interaction, in addition to being very useful for project management and sharing of information. So I think it's fair to say that we had a strong sense of the power of this technology. What we had not anticipated was that the costs for these things would drop so precipitously, so that now people have mobiles that are not terribly expensive, or they have iPads or iPods, or they have laptops, or they have desktops. The technology is within reach of an increasing segment of the world's population, even as we reach out into third world countries where the per capita incomes are pretty modest. There's a huge demand, as is illustrated by the rate of sales of mobiles that are, many of which are internet enabled.
And so, the internet is, of course, all around the world now, practically, and it has been attributed as being perhaps a contributor to the growth of democracy. Certainly with the Arab Spring, many commentators have said that the internet had a big part to do with that. How do you feel about that? Do you think the internet has had that impact?
Well, first of all, there are many things that went on to produce the Arab Spring phenomenon, but I think it's generally fair to say that the internet, where it is available, has a very powerful democratizing element, because it allows people to get access to information literally from anywhere in the world. It allows them to express their views. I would say that voices that would otherwise not be heard are amplified in that environment. And because this is not like the other mass media, it's not, a few people in the previous mass media environments had access to and control over broadcasting, whether it was newspapers or book publishing or other sorts of radio broadcast media. There were small transmitters and a large number of receivers. In the internet environment, anybody can transmit to anybody else, and so group interactions are much more readily accomplished. And as you see new applications showing up like Twitter, what you see there is, and also I think generally what you see with mobile-based applications, is this really interesting leveraging effect, going from a smart device that's capable of interacting with devices that are on the internet. And the two technologies, mobile access technology and the internet hosting or cloud computing, whatever you like, together are almost hypergolic, because the two enhance each other's utility. So each of them separately would be less interesting. Together they make for an incredibly powerful and very potent combination. Now, to come back though to Arab Spring, I think we should be thoughtful about the fact that Arab Springs happen because of brave people who are not happy with the status quo. And they choose to use whatever technologies that are available to try to accomplish their objectives. I think the internet and Twitter and some of the other, YouTube for that matter, were contributors to the ability of those people to coordinate their actions and to share with the world what was happening in their countries. The outcome of Arab Spring is not uniformly positive. We have yet to see what's going to happen in Syria. We see there's still a great deal of tension right now in Egypt. Tunisia, I think, where the first evidence of an Arab Spring occurred, has been more successful than the others. Libya is another example where it was a pretty messy outcome, and we still are not sure how that's going to work out. So I think we shouldn't pound our chest too hard about the role that internet plays in revolution. It clearly has a role to play, but revolutions, even in the presence of internet, don't guarantee to come out the way you might like them to.
Thank you. And on another note, a more negative note perhaps, some people have accused the internet of making us stupid. Have you got a view on this theory?
I remember reading that. Well, this is sort of, here, let me tell you what I imagine people who say that are thinking. Imagine, let's go back to the point where writing gets invented, okay? And you're the storyteller. You're the person who is the keeper of the stories of the tribe. And your job is to remind everybody of the history of the tribe. And then somebody comes along and invents this thing called writing, and your first reaction is, what an awful idea. My God, no one will remember anything. They'll just write it down. They won't have to remember. And that's terrible, and besides, I'll be out of a job. You know, you could see the same kind of attitudes arising. For example, how about calculators? Remember when there were big fights over should students be able to use calculators at school, and no one will be able to add and subtract anymore. May I suggest to your viewers that they read a book by E.M. Forster. The book was, I think it was written, or it's a story anyway, in around 1909, I think, called The Machine Stops. It's about a civilization in which everybody lives in their residences. They never leave. The machine is catering to their every need. They're fed, you know, remotely somehow. They communicate with each other remotely. And one day the machine stops. And people actually have to get out of their houses. You know, they have to go find food. They have to discover each other. And if I'm remembering right, and I'm sure this isn't quite correct, but the guy who turns out on top is the one that still remembers how to do arithmetic. So it is a cautionary tale about how deeply dependent we might become on computers and communications. On the other hand, I would argue that access to information has been so dramatically enhanced that as long as we're using, you know, good judgment and critical thinking about the quality of the information we find, that internet and the tools that sit on top of it, the World Wide Web, the search engines and so forth, have been stunningly beneficial in making information available and useful. So from my point of view, even though there are bad things that happen on the net, I don't dispute that, we need to do something about some of them, I still think that the net positive is enormous, because we'd have to be a really stupid species not to take advantage of the fact that we have the possibility of letting every human being on the face of the earth get access to what every other human being has learned.
Absolutely. And on a similar note, the internet has been said to have impacted modern warfare in the way that governments and perhaps insurgent groups too think about how warfare would be conducted. So do you have a view on that?
Yes, I do. First of all, I get very nervous when we toss around terms like cyber warfare and cyber crime, as if to say every bad thing on the net is an incident of national scale warfare, or every bad thing that happens is a result of a criminal action. The thing I want to emphasize here is that the bad things that happen on the net sometimes are the result of a mistake. Somebody configured something wrong, and you know, a ton of messages shows up in the wrong place, and you think you're under denial of service attack. The reason that I am concerned about the framing of these issues in cyber warfare or cyber crime terms is that we could easily react improperly and incorrectly, and possibly even respond to the wrong party based on these kinds of framings of what is detected. So here's what I really worry about. Imagine that you're responsible for protecting some portion of the net. Maybe it's a private sector thing, or maybe more importantly, it might be a national critical infrastructure. And you detect a denial of service incident, and you think it's an attack, and you think it's big enough to merit being called a nation-state attack. So now you treat this as a national security matter, and you decide that you're going to respond. And let's suppose that you decide to respond with a cyber response first. And so you launch, let's suppose it's a distributed denial of service attack, and you launch this code in the other direction, which wipes out the disks of 100,000 or 1 million machines. Well, most of those machines were probably infected by innocent parties who went to some website that had malware on it. They downloaded the web page, they got infected. Their machines are part of a botnet. They know nothing about this, absolutely nothing. And the next thing they know, the machines have been wiped out. There could be huge economic and social, to say nothing of political damage associated with the counterattack that went against the wrong parties. It gets worse. Now let's suppose that you're a national agency and you're responsible for security of borders of the country you're in, and you declare that you you reserve the right to respond to what you think is a national attack by conventional military means. So now you decide that it's your country A and country B you decide is attacking you. So you launch a counterattack using conventional weapons, or even worse, God help us, nuclear weapons. And it turns out that it was a false flag attack. It was actually country C pretending to be country B that was attacking country A, and your forensic tools weren't good enough to figure that out, so you launched the attack against the wrong country. The side effects of this are incalculably bad. So it's not that I don't agree that there could be a national level attack or that there is cybercrime going on. Of course there is. It's just that we have to be really thoughtful about how to respond, because attribution is critical. And it could very well be that some of the attacks are unwittingly supported by someone whose machine has been compromised.
How do you feel, Vint, about the recent moves to introduce legislation to perhaps limit freedom and privacy on the internet?
Well, of course, I have very mixed feelings here, because I believe that freedom of expression is very important. So all of the UN human rights elements are manifest in many ways in this internet environment. Now, I did write an op-ed in the New York Times a few months ago that was headlined, not by my doing, Internet is not a human right. And, of course, that generated quite a bit of debate. Maybe the debate was a good thing in any case. What I was trying to say there is that I didn't think a particular technology should be treated as a human right. I think that what Internet enables is a human right, which is to express oneself freely, to get access to information wherever it's available, to assemble and to confer. However, what I neglected to say, probably because I hadn't thought about it very carefully enough, is that while I don't think that we should insist that Internet itself is a human right, and I don't think we can guarantee that everyone in the world will have access to the Internet, although we hope so. However, let's suppose that the Internet is available to you and someone denies you your access to it. Now, here I think you have a violation of human rights. Because if it's available and you're denied access to it, like in the three strikes and you're out rules, I think you've really violated someone's right to expression and access to information. So that it's a very funny thing, because it's not symmetric. I don't think that you could guarantee and insist that everyone have access to the net. And frankly, even when you make it available, some people don't want it. Something like 20% of the American population say we're not interested in that stuff. I don't know why, but they do, and that's where we are. So we've kind of plateaued at about 80% of the population being online.
Do you have views, Vint, on the impact that the internet might have on education? We're seeing a lot of innovation there, I think, and it'd be interesting to get your views on what that new future might be like.
Well, I wish that I had a clearer sense of what may happen, but I can say that my eyes have been opened up by some recent events that I'm sure you're familiar with, or you wouldn't be asking this question. The Khan Academy, of course, is one example of an ability to produce useful information and make it accessible free of charge to a very large population. I'm very proud of the fact that Google actually contributed to the Khan Academy to try to help that process ahead. Many universities are beginning to offer content online, MIT among them, and I guess others that have put their curriculum online. The MIT case is interesting. Some people said, "Are you crazy?" And they said, "No, it's very straightforward. We'll put this information out there, and if somebody sees it and already understands it, they don't need to come to MIT. But if they see it and they don't understand it, then they'll realize the only way they will understand it is to come to MIT." The Stanford guys, particularly Sebastian Thrun and Peter Norvig, both at Google, but both with adjunct appointments at Stanford, offered a class in artificial intelligence a few months ago, and they thought a few hundred people were going to sign up for it, and you'll recall 160,000 people signed up for it.
Yeah, I signed up for it.
Yeah, so their first reaction, of course, is, "Oh my God, now what?" And they had to do a lot of software development to figure out how to present the class in a way that they could do automated testing. Of the 160,000 people that signed up, about 20,000 actually passed the class. And I was trying to do a little back of the envelope calculation. I'm thinking, okay, in the last 40 years, how many people have taken AI courses? And it occurred to me it was entirely possible that more people had taken that class in AI than all the students in the entire 40 or 50 years of artificial intelligence existence. So that was pretty exciting. I'll tell you one thing I am convinced is, if it isn't going to happen, at least it should happen, and I hope it does. And that is to make use of network technology to let kids learn things by doing something, as opposed to reading about it or being told about it. So learning to write a piece of software or conduct a kind of a dry chemistry experiment, or carry out tests using models that let you change the physical parameters of the universe to see what happens. The Angry Birds program, which I understand now extended itself out to Angry Birds on the moon or Mars or what have you. What I wanted was a version of Angry Birds that let the students twiddle the gravitational constants and the density of the birds, and to learn how these constants affect the behavior of the system, maybe the materials that the birds are trying to hit. By experimenting with this, you begin to get a visceral understanding of the meaning of those important parameters. I thought that would be a really cool thing to do.
Absolutely. And so, I mean, I work with a number of organizations around the use of technology and development in developing countries, both aid organizations and the technology sector. I'd be interested in your thoughts on the contribution that technology might make there towards improving the lives of people in poorer countries.
Well, the one thing I would like to share with you is a lovely speech by Jimmy Wales, the founder of Wikipedia. He was attending the Internet Society's 20th anniversary in Geneva, where a number of people were inducted into the Internet Hall of Fame. And one of the things that Jimmy said really stuck with me. In fact, several things he said stuck with me, but this one was particularly important. He pointed out that there were lots of people in Africa who were online, many of them getting access through their mobiles, and that they did the same things the rest of us do. The fact that they're a part of a developing world does not define or limit what they use the internet for. And so there were the usual scenarios. Well, they're reporting the incidence of malaria, or they're making phone calls to find out the price of fish in different ports, and then you sail into the one that pays the best. Although those things do happen, it's a mistake to pigeonhole the activities and uses of the developing world of the internet and mobile technology, because they are just like we are. They like Facebook, they like Google searches, they like all the various services that are available online, in addition to some of the ones that are more typically thought of. So I thought that was a really important observation to make. That they are moving very, very rapidly into the same kind of environment that the more developed world is, although they may be approaching it by way of mobile technology rather than fixed wire laptops and desktops.
Very interesting. So I just have two final questions. The first one is, as you look at the internet in the future, Vint, what excites you most about it, and perhaps, what are you most afraid of in terms of what might happen?
So in terms of current trends, there's no question that more mobile access is clearly on the way, with the 5.5 billion mobiles already in place. Not all of them are smartphones, and I think that percentage, which is probably 20% now, is going to go up to near 100% as time goes on. The growth rate of the net, the population on the net at 15.5% per year compounded annually, suggests that all 7 billion people will be online by the end of this decade, except for the ones who don't want to be, whatever percentage that is. The third thing is that we're seeing all forms of information showing up in digital form, whether it's music, videos, text, computer games, anything that you can digitize is showing up as an online kind of offering. That means that IP has become the bearing structure of choice for almost everything, which is pretty exciting. That my T-shirt said IP on everything, and somebody said now it should be everything on IP, which may also be true. The second thing is that because we're now extending the address space by the introduction of IPv6, we can anticipate that the Internet of Things will become more common, whether it's things like refrigerators or household appliances or picture frames or telephones that look like phones but they're voice over IP devices, sensor networks, things that you carry around on your person, buildings. I'm going to ignore that call. I hope it won't mess up your video.
That's okay, don't worry.
We live in the real world, right?
Absolutely, don't worry about it.
So the point here is that we will see a population of devices and sensor networks becoming part of the Internet environment. And that, I think, is going to open up quite a few interesting new business opportunities. For example, in the case of entertainment equipment, despite all the tussle over piracy and intellectual property, which we should talk about a bit, I see big opportunities for people who have lots of different entertainment devices that they want to keep populated with music and video and so on, or books. You can imagine turning to a third party saying, look, I have all these things and they're all part of the Internet. Here's my addresses and here's the access code. Please manage it for me. I'll just check off on your webpage the movies I want, the books I want, the music I want, and you figure out how to get it onto all these various devices. Just take care of that for me, and for some modest sum, they might do that. So that's a small example, but the monitoring of equipment, the monitoring of sensors, environmental detectors, consumption, let's see, monitoring of devices that consume resources, whether it's water, gas, oil, electricity, all feeding back to help us understand the consequences of our lifestyle decisions, possibly leading to smarter use of energy and more conscious attempt to cope with climate change, for example. All that's going to happen. There's no question. Then there's medical instrumentation. Then there is interfacing of electronics to our neural systems. And the most powerful example of this, today anyway, is cochlear implants, where you put in an electronic device which is managed by a computer program that emulates the electrical stimuli that the brain interprets as sound. I have a particular appreciation for this because my wife has 2 cochlear implants. She was absolutely stone deaf for 50 years, and then she had cochlear implants which allowed her to hear, and of course this was life transforming. I can anticipate that our neural interfaces for vision and for our ability to move our limbs about, sensory motor systems, will admit of interfaces to programmed devices, programmable devices, some of which may actually be network enabled as well. So I anticipate all of those things happening. Finally, if you don't mind my going on a bit more, there's an activity that I've been engaged in since 1998, which is to develop protocols that would allow an interplanetary internet to form. This is intended to support manned and robotic space exploration. We've reached the point, this is the group that's working on this, largely at NASA and MITRE Corporation. We now have nearly standardized the protocols. We have them on board the space station. We have them on board the rovers on Mars and the orbiters around Mars. We have them on board the Mars Science Laboratory, which is on its way to Mars. We have them on board the Apophis spacecraft, which is in orbit around the Sun and has visited 2 comets in the last 5 years. So we have the beginnings of this interplanetary capability. The Consultative Committee on Space Data Systems is standardizing this set of protocols so that all spacefaring nations could adopt them if they wish, and that would allow their spacecraft to be interoperable. But that's not the most exciting thing that's happening. The American Defense Advanced Research Projects Agency recently let a contract for a $500,000 study on the design of a spacecraft to get to the nearest star in 100 years. Mae Jemison, the former astronaut, and a group called the Icarus organization have joined forces, won the bid for that grant, and are now engaged in doing the design of this spacecraft. Your viewers will be interested to know that there are 3 big problems that I can think of anyway. The first one is propulsion. because current propulsion systems would take 65,000 years to get to the nearest star, which is 4.4 light years away, Alpha Centauri. That's just a little long, even for an ARFA experiment. So we need to work on propulsion. We have to get up to about 20% the speed of light. Oh, and then we have to slow down again and go into orbit, because otherwise we'll get 2 pictures and then, the mission will be over. Then there's the problem of navigation. Now, we all appreciate that the stars aren't where we think they are, because it takes time for light to propagate to get to us, and during that propagation period, of course, the stars have moved. So when you're trying to navigate to a star, you literally need to do mid-course corrections as you discover where it really is. Now, I've been assured that for stars that are in the nearby neighborhood, like let's say up to tens of light years away, that we have some sense for what the celestial motion is of that star system, and we may be able to autonomously navigate towards the star as we get closer to it. It certainly won't be able to do much in the way of mid-course corrections by remote steering, because the light, it could take a year or 2 years or even 4 years for the signal to actually get to the destination. Then the final question is, how do you actually communicate with something that far away? And one possibility is to use very narrow collimated lasers aimed back, for example, with the solar system. But even a highly collimated laser is going to have some beam spread. And so I need a sensor system, a synthetic aperture sensor system, which might be the size of the solar system, in order to collect enough of the signal to receive the data that's coming back from this remote spacecraft. And as to the actual generation of a detectable signal, some of us think that a femtosecond laser, 10 to the minus 15 second laser, would give a very, very big pulse, especially if you were sending, let's say, 100 watts, or even 10 watts. 10 to the minus 15 seconds, 10 watts is a lot. And so that should give a big spike. So now I know why I have to build the interplanetary backbone, and so I can receive signals coming from the interstellar spacecraft that this group is going to design. So that's the latest stuff, looking at trends currently. Very
fascinating, Vin. And so my final question is one I like to ask most people I interview. It's the students who are watching this, most of them will be going into the world of work or on perhaps to postgraduate study in the not too distant future. Based on the experiences you've had, what would you like to say to them? What would you think would be the advice you'd like to give them?
So, first of all, I think that it's smart to go into some aspect of computer science right now. So many things are depending on the network and the applications that can run on it. Second, security is a big issue. We need better operating systems. We need paranoid browsers. I've been trying to convince the guys at Google that the next version of Android should be called Paranoid. The whole point here is to be conscious of the possibility of malware coming in and trying to resist it, detect it, mitigate its effects. So that's a big area of concern. The third thing is that policy for let me call it the governance of the internet really needs to be thoughtfully explored. We have some actors, some state actors, that would like more control over the internet. They fear it because the population sharing information might oust the sitting government. And, of course, the Arab Spring is an illustration of that possibility. On the other hand, as you asked earlier, the internet has a democratizing influence on populations. And, of course, from the American point of view, that's a good thing. So I think that if I were urging people to consider careers in computer science, I would be pushing them towards artificial intelligence, towards scaling up big data, towards security, towards the now to come back to something we earlier talked about, and that's intellectual property and intellectual property protection. I'm persuaded that the older models of intellectual property protection, which were based on preventing people from making physical copies of things, is not working very well in the digital environment because it's so easy to copy and redistribute virtually anything. In fact, if you think of the World Wide Web for a minute, think about how a browser works. It reaches out on the net and it copies the home page, and then it renders it. So this web is a giant copying engine. I know that the intellectual property world is just beside itself because of that. So this suggests to me that new business models are needed to monetize the kinds of works that we want people to continue to create, but we have to find a way to allow them to monetize this without imposing such drastic constraints on the internet that we lose all the human rights that it supports right now. This doesn't mean that we should ignore the bad things that happen on the net. It doesn't mean that we should ignore piracy or anything else, but it does mean we should be very thoughtful about how we introduce mitigating capabilities into the net in order to make it safer for people to use. This means pushing against various kinds of malware. It means allowing some means of protecting intellectual property where the creator wishes. And here I want to emphasize the notion of the Creative Commons, which gives quite a spectrum of protection, including none. This work is available in the public domain all the way over to the other side, whereas you can't have any of this unless you pay me. The thing that Larry Lessig triggered in many people's minds with his Creative Commons idea is that not every author is insisting on getting paid for the creation of a work. Some of them are very satisfied to know that it was useful to someone else. So here I think we have a lot of work to do on the policy framework for protecting intellectual property, and I'm looking forward to that debate over the next several years. The other thing to be watching out for is the attempt by ITU and others to somehow gain control over the internet and constrain its utility. And even if that isn't their primary objective, certainly they want to get more control of the system. And here I think that not our friend, that we want as much openness as we can possibly get, consistent with making people not only feel but be safe on the net, while at the same time allowing them to express themselves freely.
Thank you, Vint. It's been a great pleasure to talk to you today, and I know that what you've said is going to be very valuable to the students at Waterloo, so thanks very much for doing this.
Well, I'm delighted to do this, Peter, and I certainly hope that the students want to react to any of this, that they'll feel free to send me email. I'm vint@google.com. In the meantime, I'll see you on the net.